3 notes. We left off on the first derivative test. Okay, so it's very similar to what we were doing yesterday. I'll refresh your memory. Where we are finding where our function is increasing and decreasing with our derivatives. So we found critical points, meaning where do we have slopes of 0, horizontal tangents, or parts where our derivative is undefined. And then we created a sines chart. And anytime our derivative had a negative value, that means our slopes at all those tangent points were negative. We knew it was decreasing. And then every time our tangent lines were positive, like so, our derivative was positive, so we knew it was increasing. Okay, so now we're basically going to do the same thing, but apply relative extrema. So where are like maxes and mins? So basically we're going to do the same steps. We're going to find the critical points. We're going to create a sign chart, test the intervals and our derivative. And if our derivative changes sign from negative to positive at a critical point, we know that there's a relative min there. Okay, so picture this is obviously my critical point right here. So if I test to the left and I have negative slopes, test to the right and I have positive, then we can conclude by this first derivatives test that there's going to be a relative or a local minimum. Okay. If my sign changes from positive to negative at that critical point, then I know I'm going to have a relative max. If it doesn't change sign, then it's still considered a critical point. There's still a horizontal tangent here. However, it's not a max or a min. Okay, because in order to be a relative max or min in its little area here, it has to be like the lowest or the highest point. So if you kind of like zoom in here, you know, for example, like this isn't the lowest point. There's a lower point over here. But when we do that with our true maxes and mins, we can see like, okay, in that little area, that is a relative min or a relative max. Okay, so that's the first derivatives test pretty much. So now I threw in some Schrödinger functions, not just some nice polynomials. And then I gave us one 2/3 root on the next one. Okay, so I laid out kind of like steps on applying the first derivative test for you. So the first thing we gotta do is find the critical points, which means we gotta find the derivative. Here's step 1 here, find the derivative, which is just 1/2 minus cosine. Remember, our critical points can occur at 2 locations. First, horizontal tangents when the derivative is 0. Second thing you got to check is where your derivative is undefined. And since my cosine function is defined for all real numbers, my domain is all real numbers for a cosine curve. There's none there we have to worry about. Here we could solve this. I'd move the cosine over here. All right, so we're looking on the interval 0 to 2 pi. We need to know where cosine is 1/2. Okay, so I'm thinking cosine is x, so I really only need to find my first ones here. 3, 2, 1. Cosine is 1/2. That's 60 degrees, or pi over 3 in radians. So we know cosine is positive 1/2 in quadrant 1, so pi over 3. What other quadrant is cosine positive? 4. Yep, 4 over here because it's x. So then you have to find the pi over 3 angle of quadrant 4, as I kind of like to call it. So I think this would be like 6 pi over 3, that'd be 2 pi, so this one would be 5 pi over 3. All right, so those are our 2 horizontal tangents in the interval 0 to 2 pi. Okay, first step done. There's my critical points. You can circle them if you want to. We just have 2. Use the critical points to create intervals for a sign chart. Move this over a little bit so I see them. 2, create sign chart. I'll pop right in, right?
Oh yeah.
You guys think that's the first time I've done that? Thanks. Okay. So we have pi over 3. And we have 5 pi over 3. Okay, let me show you guys something I like to do to save myself time. Now, obviously, if we don't have our calculators with us, we have to know how to do this in our head. But if you do have your calculators, sometimes I just like to type my derivative like into my calculator. So my derivative is at 1/2. Let me do parentheses actually. 1/2 minus the cosine of x. And then I will just like type in what I want to test here, and it'll just give me the values right away. So if I want to test something to the left of pi over 3, I would probably do 0. And remember, we're finding the sign of the derivative. So we're testing them in f prime, our derivative function. That's like our third step. Test in derivative. So I'd probably do 0. I did pi. Pi is obviously in between pi over 3 and 5 pi over 3. And then I did 2 pi. And I knew those were like some nice, easy. So I shouldn't crutch your mental math ability because we should be able to do that pretty easily, right? Cosine of 0 is 1. So 1/2 minus 1 is -1/2. Or, you know, you can just do this 0, pi, and 2 pi. And bingo, you basically, all you're looking at is the sign. You don't even really have to write the value down. Like, oh, it's negative. The derivative is negative. So you could just, I would be A-okay with you showing me this in your work. Like, oh, this is negative. Less than 0. 2 pi, that one was also negative. You don't even have to write down the value. You're really just looking at the sign. This one's also negative. This one's positive. This one's negative. If you want to write down the value, you can. We obviously get -1/2 here. Like I said, this one was easy to do in our heads. Probably wasn't the best example for me to show you that calculator hack, but you get the idea. Okay, so obviously this one's negative, this one's positive, this one's negative. Let's write that in our chart. Here we're negative, here we're positive, here we're negative. Okay, so what we did yesterday was talk about where it was decreasing and increasing, and I showed you to kind of draw in decreasing slope, positive slope, decreasing slope, and I think this visual really helps you with locating extrema. Okay. So if my function changes from decreasing to increasing, would that point right there be a min or a max? A min, right? So we could say f of x has a relative minimum. It's not the absolute. We just know in that area it's a relative minimum at pi over 3. If they asked for like the actual point, you would just plug pi over 3 into the original, right? And you could get the ordered pair, but because here's our justification, and this is where I've seen it like on AP exams when you're locating relative maximum minimum using the first derivative test, like to justify. So this would be like how you would justify, because the derivative changes from, it goes from negative to positive at x equals pi over 3. Okay, so I'm going to just bullet point that. They're not asking me to identify my increasing or decreasing intervals, just the relative extrema. Okay, then I see this other critical point. My derivative changes from positive to negative, so picture that. We'd have a relative max. Okay, our justification is going to be similar. Our function has a relative maximum at 5 pi over 3 because connecting it to our derivative changes from positive to negative. So again, you wouldn't really want to justify this saying like, oh, our function changes from increasing to decreasing, because that's like algebra 2. If we're taking the AP Calc exam, you want to connect it to the derivative. You want to connect it to the calculus part. Changes from positive to negative at 5 pi over 3. Okay, I'm going to graph this original curve quick so you can kind of visualize what we just found. I always like to do that, see if it makes sense. 1/2 x minus sin x. And we're only looking 0 to 2 pi. Okay, it's already set. Oh, this goes a little higher. Better zoom out here. Let's try that. There we go. Okay. So we found this first critical point right here. That would be my pi over 3 one. And then this one right here at 5 pi over 3. So you can see how my function, changes from decreasing to increasing. Or think of this in terms of derivative. Our derivatives here would be negative, negative, negative. Then they change to positive, 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 positive. So that locates the relative min. This one changes from positive back to negative. Okay. Make sense? Let's try one more. I like this next problem because it puts it all together. It says, I think these are similar to like the ones on your homework where you're going to have to do the first derivative test, and we're going to use it to kind of talk about like basically everything we've done in this lesson. So find the critical numbers or critical points, figure out where it's increasing, decreasing, and then also identify any relative extrema, and then we'll use a graphing calculator to confirm our results, basically like we just did. Oh yeah, so many good steps here. Okay, so let's start with finding the critical numbers. Part A. So I'd find my derivative, which would be 2/3 x squared minus 4. 2/3 minus 1 would be negative 1/3. Chain rule times by 2x. All right, let's simplify that a little bit. So I have 2 times 2x in my numerator, that'd be 4x. In my denominator, I have 3. Move that x squared minus 4 to the denominator for the positive 1/3. Okay, so to find my critical points, or critical numbers, so there's the same thing. First, when is this equal to 0? Second, where is this undefined? All right, I'll start with this is equal to 0. Multiply both sides by the denominator. You get 0 is 4x. So x is 0 is a critical point, critical number. Where is my derivative undefined? When my denominator is 0. Okay, so obviously you could divide both sides by 3, cube root both sides, we get here. Okay, you could either factor or solve using square roots, that's at positive and negative 2. All right, we need to solve that. Okay, that part's done. There's my critical numbers, part A. B, find the open intervals on which the function is increasing or decreasing. So for this, I gotta create a sign chart. So I'll do that over here like I usually do. So we have 3 critical points. All right. So I'm going to test these in my derivative. So I did my simple -3, -1, 1, and 3. Now this would be a good one to like use our calculator for. So I'm going to type my derivative function because that's where I'm plugging these test points in. So I'm going to take my calculator. This is honestly what I do when I'm doing these problems just to save time. I'm going to type my derivative in. Careful with this. We have our rational function here, so you got to wrap both the numerator and denominator in parentheses. Got to be really careful. All right, so my denominator would look like this. Parentheses, 3, parentheses, x squared minus 4, close parenthesis, to the power of, parenthesis, 1/3, parenthesis, close your denominator, parenthesis. That's what you should do to type that in. Okay, then I would just use my table feature. Like, hey, I'm just going to plug in the numbers I want to test. So I did like -3, -1, 1, and 3. And again, all I care about is the signs. You don't have to jot down these nasty decimals. We see it's negative, positive, negative, positive. Negative at f prime of -3. So again, you really just need to do this to show me. It's less than 0. It's negative there. F prime of -1, positive. There. F prime of 1. Oh, negative. F prime of 3, positive. Those other numbers in my table are just left over from the last problem. Positive. This one's greater than 0.
I think you fell to your own pattern. It's negative, negative, positive, positive. That you showed on your thing. You just automatically read it as negative, positive, negative, positive.
Is that not right?
Yeah, because the 2 are in there, you just look at what it's going to be 4 times, and then it's going to be negative, negative, positive, positive.
Say that again?
It's. Wait, how did that work?
I'm clearing these out. Maybe I don't want these. Maybe it won't let me clear those out. Okay, sorry.
Just hit delete.
Never mind.
Thanks. Perfect. Okay. Good, Dalton?
Yeah, I'm good.
I picked a more harmless question for you where it doesn't have this pattern. It's coming up soon, don't worry. I was like, Dalton will like this one. Okay. So, now B wants me to locate our increasing and decreasing intervals. So you can just list them like this. Increasing. Increasing, obviously, when my derivatives are positive. So that would be -2 to 0. And 2 to infinity. I'm going to box that because this is my answer for part B. Decreasing. When all my derivatives are negative, because that's saying all those slopes at those instantaneous rates of changes are negative, would be -infinity to -2, 0 to 2. Okay, part B is done. Part C says, now apply the first derivatives test to identify all relative extrema. So we can use our sign chart from part B. Let's go ahead and draw those pieces in. So it goes decreasing, increasing, decreasing, increasing. So I see that I have 2 relatives min, one right here at -2, one right here at +2. You don't have to say this every time, but it's because the derivative changes from negative to positive. Just shorthand it. And then I have one relative max, it looks like. At x equals 0. Because our derivative changes from positive to negative. If it asks for like the actual points, it just says to identify all relative extrema. I did like plug those numbers into the original function here. So here, when I plugged in 2, I got out 0, obviously, because you have 2 squared minus 4. So 2 zeros, that actual ordered pair. Negative 2 zeros, that ordered pair. We'll take a look at the graph in a second here. And then when I plugged in 0, okay, I get the cube root of negative 4 squared. So that's like the cube root of 16, right? Yeah. Cube root of 16. That can be reduced, but that's fine for now. Because 8's a perfect cube, so you could write that like that. 8 times 2. Cube root of 8 is 2. Anyways, AP exam, you usually just have to find the x values. But that would be how you find the order pairs. Obviously, just put them into the original. Okay, D says this is done now. D says let's use our graphing calculator to confirm our results. So I'm not looking at the graph of the derivatives. I can clear that out. I want to look at the original function, which is x squared minus 4 to the 2/3 power. I always like to wrap my rational exponents in parentheses as well, just to be safe. Okay, now for my window, obviously I have some critical points at -2, 0, and 2. So let's maybe just look -3 to 3. And then I might zoom out here a little bit more. I might go -10 to 10. We'll see. Okay. So keep in mind, the first step when we found the critical points, the one where the derivative was equal to 0 was at x equals 0. So that means we had a horizontal tangent here. That makes sense. The other 2 critical points were where my derivative was undefined, where my derivative doesn't exist. And that's at these cusps, -2 and 2. Okay, I can see, similar to like my little drawing here, all my slopes are negative. My function's decreasing on -infinity to 2. Now I'm kind of confirming my answers for part B. Decreasing from -2 to 2. Decreasing from 0 to 2. Cool. Calculus works. Increasing from -2 to 0. Increasing from 2 to infinity. And we also have extrema. Two relative mins, positive -2, and one relative max. Awesome. Now, if we were to ask for absolute or like global extrema, if we were just looking at these intervals, looks like my endpoints would probably be the highest point on my graph. I would argue that's a little bit higher than this one. And 0 would probably be my absolute minimum. But that was that candidates test we talked about earlier. Okay, that's it for 3.3. Yep, 3.3.
Do you have to put anything for D, or would you just like?
I'm not too picky. I would just do this. GC confirmed. I go with that. You don't have to draw the graph. I trust that you check it. If you don't, you're only hurting yourself. Okay, I'm gonna stop this recording. This will go under a different category than this.